All right, so welcome back. So in this video, I'll talk about deviation, variance, and standard deviation. So this is a topic which is kind of introduced within statistics. Not a lot of students do it until they do actual statistics. So I'll try to give it to you through an example that you see here. So I have about 20 sample points within here. So let's say these could be percentages, okay, so maybe grades of students within some huge cohort, and then I just took 20 of them. So for all of these, deviation, variance, and standard deviation, so there is in particular for variance and standard deviation, statisticians like to utilize kind of different symbols. So if you have your entire population data, you will use one particular set of symbols. If you're just talking about a sample data from the population, then you'll use a different set of symbols. So I will try to introduce those to you in this video as well. It's not really that big of a deal. It's just a matter of separating when you are concentrating on a sample and then when you are concentrating on an entire population. So let's take this and then I'll break down deviation, variance, and standard deviation to you. So again, so let's assume, for the purposes of this video, I'm going to assume that this is coming from some sampling techniques from an entire population. So I have taken 20 random samples of, let's say, student scores. Now, the first thing that you should know how to do, of course, is how to calculate mean. Now, I have done a video on mean, median, mode, and midpoint or mid-range. So I'll do a link, so I'll provide you a link up above to that particular video so you can have it, okay, just in case. And in here, if I would take all of this data, I could calculate the mean by simply adding it all up. So that's exactly what I have done right here. So I've added them up. I have 20 data sample points. And now I have done the calculation, so the division, and then the answer is approximately 74.6. It's actually 74.55. I rounded it to one decimal place. Now that's my mean. Now for our mean, we like to utilize the symbol X, and then we put a line above it, and we call it bar. Okay, so this X bar that we have, so I'm going to refer to this as basically the mean. Okay, so this symbol represents the mean of the entire data. Now we need that because our deviation, our variance, and standard deviation is dependent on our mean. Okay, now these particular deviation, variance, and standard deviations are sometimes referred to as measures of dispersion. So dispersion means just how spread out your actual data is away from the center that you may have. And I'm going to show you all the different calculations, and then towards the end of the video I might kind of talk about, okay, kind of the details of, that separation that you may have, so that it gives you some sense of understanding and intuition. So first off, deviation. All right, so in order to do deviation, just to make my life a little bit easier, so what I'm going to do is I'm going to take this entire data set and I'm going to order it. I'm going to order it from smallest to largest. Now, I'm only doing it for convenience. I don't have to necessarily do that, but I'm going to do that for convenience. All right, so here, so what I've done is, okay, so I've kind of preloaded. Now, this is now ordered from the smallest to the largest. So notice each column, so it's going 41, 45, 55, and now it continues up and down until we get to our largest sample point. Now, once I have this, if you want to calculate what your deviation is actually very simple, and deviation is referring to only a single data point. So that's interesting. And how do we calculate the deviation? So the deviation for a single point, or a single data point, so deviation for one data point, so one data point is simply defined as, we take the data point that you have and you're going to subtract the mean from it. And what that tells you is how far away are you from the mean. Now, if the answer is negative, that means you are to the left of the mean, if you were drawing a number line. And if the answer is positive, that means that you are to the right of the mean. So for instance, in our situation, so what we have is if I would draw my number line in here, so I know that my largest point is going to be here 100. My smallest point is going to be 41. Now I've calculated my mean. Now I'm going to kind of guess in here. So my mean is, somewhere around here, and it was 74.6. So any data point which is going to lie on this side, and if I would do this calculation for it, then what I would find is I would get a negative answer. If, on the other hand, I have a data point which lies on the right-hand side, in this way, and I would do this calculation again, I would find that my deviation would be positive. So here would be positive, and here it would be negative. So that's what you would find. So I'm going to construct, the entire deviation. I'm going to start creating a table for myself, and I'm going to do it in kind of fast-forward mode. And after I finish, so I'll come back and we'll talk about those deviations. All right, so see you in a few seconds for you, not so few for me. All right, so welcome back. So I'm just constructing basically a table, and within this table, on the left-hand side, here I have all my data points. So I have 41, 45, 55, and so on. And now I'm going to construct my deviations for each data point. So I'm going to do the first few and talk through it so that you understand it. So for instance, my first one that I would have, so this would be simply 41 minus the mean. So this would be 74.6. And if I subtract these, so if I take this, you'll notice that, of course, it's going to be negative, so 74.6. So the answer is here, negative 33.6. Now, what does that mean? It means that this data point deviates from the mean by 33.6 to the left of it. So the negative means that it's to the left. The 33.6 means that that is how far away it is from the mean, from the average. And now you would continue that, and you would do that for every single point to see their deviations. So let me do that, and again, I'll fast forward that for you, but I'm going to create the entire table all the way down. All right, so see you in a few moments. All right, so welcome back. So notice I have calculated the deviation for each data point. Now, because I have ordered them from the smallest to the largest, you'll notice that the biggest negative is on top, and then the negatives just kind of decrease, okay? So they get bigger and bigger and bigger. So now bigger because we're going in the right direction on the number line. And then eventually we kind of run out of the negatives, and then we start going positive. And again, that's because the mean is basically 74.6. So you will notice that within here, so in this kind of split right here, because that's where around the mean is, that's where it separates the negatives from the positives. Now, what is interesting is that the deviation, if you would add up your entire deviation, so if you would take all of these values, so if I take all of these values, so now again, so this means sum of all my deviations. So this right here means the sum. So I'm going to be adding all of these up. So if I added all of these and went all the way down, so on, then I would find something very interesting. Okay, so if you would add all of them, you would find that your answer would actually be 0. So that's pretty neat, okay, to be able to see that. And the reason for that is because you have found the mean, right? The mean is the average of all of them. So if you're going to be subtracting the average away from the data points and then you're going to be adding it all up together, right, you will actually get 0, okay, just by definition. All right, so this is what's going to happen in this particular observation. So that's the deviation. So that's not a big deal. So deviation pertains to a single data point. So the next item on our agenda is now the variance. All right. Now, because what I am referring to here is I took 20 sample points. So my variance that I have, because I am taking these sample points of 20 data collected, so I'm not using the entire population. So here I do want to give you a little bit of, okay, a key difference. If you are talking about a sample, okay, versus a population, then you do have to specify if it's a sample variance or if it is a population variance. To calculate them is exactly the same, but the symbol you will use is going to be different. And those researchers or statisticians or you as students, okay, just by looking at the symbol, you can tell if it's a sample variance or if it's a population variance. So first, let's calculate the variance itself. And then, okay, I'm going to give you the actual symbol. So the variance I'm going to construct in the next column. So I'm going to take this column right here, okay, and what I'm going to do is I'm going to go all the way down. So I'm going to create this and extend it all the way down here. And now my variance is defined as the following. So this is, because it's a sample variance, so I should write this in here. Okay, so this is the sample variance. All right, so I'll put that there. And what it is it is your deviation that you have. So that's your deviation that you carry squared. So that's what you have with respect to your variance. Because you notice that all of these values here on the left in that second column, they're either negative or positive. Now, the sample variance basically takes those deviations and squares them to make all of them positive. And then you will see that from that variance, we can actually obtain the next, which is the last one, which is called the standard deviation. Okay, and I'll show you how we calculate this sample variance. Okay, so the sample variance, okay, now for a single data point, is basically done exactly in the same way. So you can take your value. Now we've already calculated these. So what you can take is you're going to take negative. So I'm going to take negative 33.6 and I'm going to square it. So this is going to be to the second power. And I'm going to get, now in this case, it's going to be a pretty big number. All right. So let me write that in here. So that's going to be 1128.96. But notice that it is now positive. But that's just for that single point. All right. So now what I'm going to do is I'm going to fill out the entire table again in fast forward motion for all the variances for each data point. And then we're going to calculate the overall sample variance. All right. And I'll show you how to do that. Okay. So we'll see you in a few moments. All right, so welcome back. So that took a little bit of time. Now, of course, because statistics deals with numerous and very large data samples. Okay, so in terms of the samples that we have, you typically would most likely do this on a spreadsheet. You wouldn't suffer like I do. Okay, but what I wanted to do is I wanted to kind of teach you. So showing you exactly how it's done is sometimes helpful, right? Now, I have calculated my sample variances for each data point. Now, here is the actual sample variance. The definition of it, what we must do now is we must take our entire, so what we're going to do is we're going to be adding all of this up. So we're going to add this entire column up. All right, so now the addition of these, okay, so again, so the addition is this symbol. We're going to take our, but now we're squaring them, notice. So it's not going to be equal to 0 because they're all positive. And here is the key distinction. For sample variance, okay, once we add all of these up, if you want to know what the sample variance is, so if you're dealing with a sample and not a population, then the result becomes that you take your individual data variances and you're going to divide this entire total by the number of samples that you have minus 1. So that is if you have a sample variance and if it's not actually the entire population. If you have the entire population, then what we do is instead we take still the same thing. So we take our variance for individual data point, but now we will divide by the entire population size. Now the population size, we typically will try to write it with a capital N instead of a small n, but to be honest, it doesn't matter. Now you might say, what's the difference? Why do we do it? Well, when you're just learning the introductory concepts, so typically, okay, so there won't be a grandiose explanation of that. It turns out that if you continued to study statistics, you would find that doing the division by n minus 1 is a better approximation to the overall population variance. So they have found that, okay, and of course there's ways to show that. I'm not going to do that in this video, but that's the reason why. So when you're just beginning, unfortunately, you're kind of stuck and you have to take the sample variances and you're going to be dividing by n minus 1. But keep in mind that the reason for that is because it better approximates the overall variance most of the time. Okay, so that's what they do. Now, the other key thing is that when you're reading these things, that what statisticians will do is when they're referring to the sample variance, they actually use the symbol for this. So the symbol for this, let me shift this a little bit. So the symbol that they use is S, okay, for the sample variance, okay? And the squared means because you are actually squaring all your deviations. So that's why they put this symbol. So overall, what you're going to find, and you'll see that in some literature, most literature, you're going to find that the sample variance is given as S squared. So it's a small s squared. That's a sample variance. While if you're talking about the overall population, so if you're talking about the population variance, and you're calculating this right here, so if you kind of calculate that, then they use a different symbol for that. And that symbol that they used is they use the Greek sigma squared. So this is my sigma squared. You can take a look at it, okay? And that's what it is. Now, they represent, of course, they both mean variance, but they just use a different symbol, and the symbol is utilized. So the S is used for sample variance, okay, and the sigma is used for population variance. So that's what you have. All right. So we can take this entire thing, we can add it all up, and we can find out exactly what, in this case, what our sample variance would be. So let me do that. I'll add all of them up again in fast forward motion. And then I'm going to come back and we're going to calculate, in our case, we're going to calculate this. All right, because we're talking about sample variance and not population variance. All right, so we'll see you in a few moments, okay? All right, so welcome back. So I've added all of it up together, so it's 4447. And now, because it's a sample variance, I have 20 minus 1. So my S squared, so my sample variance is equal to, so now I can take 4447 divided by 19, and that will be 234. All right, so that would have been my answer. Okay, so 234 is my sample variance. All right, so this is what I have, okay, for this. Now, the last item, all right, in this video is basically your standard deviation. Because of the fact that our variance is squared, all right, having this number, may throw you off, because notice that, for instance, we had between 41 and 100 are data sample points. So this 234, you might think, well, what does this exactly mean? So another very nice kind of observational thing with respect to measuring the dispersion, instead of taking the variance, what we do is we often talk about something called the standard deviation. Now, the word deviation, you know what that means per one individual point, because we've just done that in this video. But the standard deviation basically takes your variance and takes the square root of it. So what we do is, okay, our standard deviation S, okay, if you take the square root of both sides, so if you do this, this gives you the standard deviation of our answer. So 234, and we wanted to take, the square root of it. So that would be approximately 15. Okay, so what does this 15 mean? So that standard deviation, so the deviation on its own, when we were drawing out, so here, when we had our timeline, so what this is saying is that most of the, okay, so let's say here and here, okay, so that is S and S, all right, so these are my standard deviation. It says that most of the data, okay, will fall somewhere in between here. And this is assuming that the data is nicely evenly spread out. Okay, so this is not always true for all of it, because if they're very dispersed, if they're very far away from each other, okay, then it may not necessarily mean so. However, okay, that's what a standard deviation is. So if you would take at random these points, okay, out of my entire sample space, so if I had all of these, and I would take it at random, then I would find that they possibly may fall within around 15, okay, so in this case, so around 15 away from your mean. And that's how you actually calculate your standard deviation. Now, if you were calculating the population, all right, so the standard deviation, so you find that this would be sigma, okay, and then you would have to take the square root of this right here if you were counting the entire population size. All right, so this is something that you would have, and this is how you calculate, okay, and find deviation. This is how you find the variance, so either sample or the population variance, and this is how you will find the standard deviation. So the standard deviation for the sample is simply designated by an S, while S squared is the sample variance, and the standard deviation for the population is designated with a sigma, and sigma squared is the population variance. And that completes this particular video. So thanks for watching, and we'll see you in future ones. Bye, everybody.